Space travel has long fascinated humanity. From the earliest depictions of the heavens to the modern era of satellites and probes, we have always sought ways to explore the unknown. But as remarkable as chemical rockets are, they are not the end of the story. In our quest to push farther into the universe, we've turned to an idea that seems almost magical: space sails. These elegant, lightweight devices harness the power of light itself to propel spacecraft, promising a future where interstellar journeys become not only possible but practical. Space sails, also known as solar sails, operate on a simple yet revolutionary principle: the momentum of photons. Photons, the particles of light, might be massless, but they still carry momentum. When they strike a surface, they impart a tiny push. Over time, with enough photons and a large enough surface, this push accumulates, propelling a spacecraft forward without the need for fuel. This concept isn't new. In fact, it was first proposed by the legendary astronomer Johannes Kepler in the early 17th century. Observing comets and their tails, Kepler theorized that some kind of solar wind was responsible for pushing these tails away from the sun. While he couldn't have known about photons, his insight laid the groundwork for the idea of solar sailing. Fast forward to the 20th century, and the idea began to gain traction in the scientific community. Visionaries like Konstantin Tsiolkovsky, the father of astronautics, and Carl Sagan, the renowned astrophysicist, championed the potential of solar sails. It was Sagan, during a 1976 interview, who introduced the concept to a broader audience, demonstrating how sunlight could become humanity's ticket to interstellar travel. But how do these sails work in practice? The answer lies in their design. Space sails are made from incredibly thin, lightweight materials, often just a few microns thick, such as mylar or captain. These materials are not only reflective but also durable, able to withstand the harsh conditions of space. The sail must be enormous to capture enough light to generate thrust, often stretching tens or even hundreds of meters across. For example, the Japanese spacecraft Icaros, launched in 2010, featured a sail 20 meters in diameter. Despite its size, the sail weighed just a few kilograms. The deployment of a space sail is a delicate process. Packed tightly during launch, the sail unfurls once the spacecraft is in orbit. This maneuver must be precise to avoid tearing or tangling. Once fully deployed, the sail begins to capture sunlight. Unlike conventional propulsion systems, the acceleration from a space sail is gradual but continuous. Over weeks, months, or even years, this constant thrust can build up incredible speeds, making solar sails ideal for long-duration missions. One of the most exciting aspects of solar sails is their potential for interstellar exploration. Traditional rockets are limited by the amount of fuel they can carry, but space sails have no such constraint. They are powered by the sun's energy, which is free and abundant. As long as a sail remains intact and oriented correctly, it can continue accelerating indefinitely, limited only by the diminishing intensity of sunlight as the spacecraft moves farther from the sun. But what happens when sunlight becomes too weak? This is where other light sources come into play. Powerful lasers, stationed in orbit or on planetary surfaces, could beam concentrated light onto the sail, providing the necessary push to propel it beyond our solar system. This concept, known as laser sailing, is a cornerstone of ambitious projects like Breakthrough Starshot. Proposed in 2016 by physicist Stephen Hawking and entrepreneur Yuri Milner, Breakthrough Starshot aims to send tiny laser-powered spacecraft to Alpha Centauri, our closest stellar neighbor, at 20% the speed of light. If successful, such a mission could reach its destination in just over 20 years. The challenges of space sails are as daunting as their potential is vast. Designing sails that can withstand micrometeoroid impacts, radiation, and extreme temperature fluctuations is no small feat. Precision is critical. Even a slight misalignment could render a mission ineffective. Additionally, the development of powerful and efficient lasers for interstellar sailing is still in its infancy. But despite these hurdles, the progress made so far is nothing short of extraordinary. In recent years, we've witnessed remarkable milestones in solar sail technology. The Planetary Society's LightSail program, funded by public donations, successfully demonstrated the viability of solar sails in Earth orbit. LightSail 2, launched in 2019, became the first spacecraft to use sunlight for controlled propulsion, a breakthrough that proved the concept's potential for practical applications. What lies ahead for space sails? The possibilities are as limitless as space itself. Beyond interstellar travel, solar sails could revolutionize how we explore our own solar system. They could enable missions to the outer planets and their moons, carry probes to study asteroids and comets, or even serve as space tugs, transporting cargo between Earth and Mars. Furthermore, space sails could play a crucial role in planetary defense, swiftly delivering deflection devices to intercept hazardous asteroids. In the distant future, we might even see solar sails integrated into massive space structures, such as space habitats or orbital cities. By harnessing sunlight for both propulsion and energy, these structures could maintain their orbits and adjust their positions without relying on traditional engines. The dream of a self-sustaining human presence in space could become a reality, thanks in part to the humble yet revolutionary space sail. As we stand on the cusp of a new era in space exploration, space sails remind us of the power of ingenuity and imagination. They are a testament to humanity's ability to turn the simplest ideas, like the push of sunlight, into tools for exploring the cosmos. With each step forward, we come closer to realizing the dream of interstellar travel, unlocking the mysteries of the universe, and securing our place among the stars. Space exploration with solar sails is still in its infancy. However, as technological advancements accelerate, solar sails might pave the way for a future where reaching the stars is no longer a distant dream, but a tangible reality. Expanding efforts in partnerships globally, NASA, ESA, and private ventures like SpaceX could utilize hybrid methods blending chemical propulsion with long sail durations. The vision for solar sails extends beyond propulsion. Imagine a fleet of sail-equipped satellites forming a reflective shield to help regulate planetary temperatures or redirect solar radiation. Such applications could provide innovative solutions to climate challenges on Earth or aid terraforming efforts on Mars. By leveraging their simplicity and versatility, solar sails could redefine how humanity interacts with space and planetary environments. Looking ahead, missions to the icy moons of Jupiter and Saturn could benefit from solar sail technologies. With no need to carry bulky fuel reserves, such missions could dedicate more mass to scientific instruments, enabling groundbreaking discoveries. From exploring subsurface oceans to studying the chemical composition of distant worlds, solar sails hold the key to unlocking some of the most profound mysteries in our solar system. The promise of solar sails is vast, and the journey to fully realizing their potential is just beginning. As humanity continues to innovate and dream, these shimmering beacons of light will guide us further into the great unknown, ensuring that our voyage through the stars is only just getting started.